Okay, so this illustration sort of emphasizes or symbolizes what I'm going to talk about. You can see this image inside the head. There's an image of a thinking person. And the metaphor is that, or the question is whether we could somehow make this inner person within us think harder if we provide them with incentives. Okay, and incentives are symbolized with the very common carrot and stick as well. So it's kind of a different question or a different usage of incentive from the use of incentives to promote a certain behavior and then giving incentives for doing something. It's just giving incentives for doing things right. And the question is whether this could make us somehow, in parentheses, smarter. Okay, that's the question I'm going to talk about. And this talk is based on two papers. One is in press in JDDM, and the other is going to be submitted hopefully this week. And both of them are with Dana Zeff, who is also here in the audience, PhD student of mine. Okay, so in psychology, although there's never a consensus about anything, it is generally agreed that incentives have a positive effect on cognitive performance, although some questions remain. For example, in a paper published in a journal called Performance Improvement Quarterly, Condley et al. Found a Cohen's d of 0.60, a medium to large positive effect of incentives on performance. You might say this is not a surprise given the name of the journal. In a much more extensive literature review and meta-analysis, Ceroseli et al. Finds a somewhat smaller effect size of 0.30 that is still significant and robust. They found a positive effect in school, work, physical domain, lab, and field studies. There are some moderators. It was stronger in measures of quantity than quality, but it was an overall strong effect. And Shaw and Gupta summarized the literature and say something like, in short, the corrosive effect of financial incentive on intrinsic motivation in the workplace are mythical, and the evidence conclusively demonstrate their beneficial effect instead. Okay? Now, what happens in behavioral economics? Do you see, by the way, the next slide? Great. So I'm going to focus on the effect of incentive on judgment performance in order sort of to make some boundaries around the questions of interest. I'm going to ask whether incentives improve judgment performance and reduce judgment biases. And there were many null findings in psychology in this respect. For example, you see here under null findings, all kinds of studies that didn't find an effect of incentives in various judgment biases. And there were also some positive findings. And as you can imagine, this has naturally led to a plethora of opinions. Some say there's no effect of incentive. For example, Kahneman and Tversky, 1983, say something like this. Our subject followed the representativeness heuristic, even in choices involving substantial payoffs. So we do not share Dennis Lindley's optimistic opinion that inside every incoherent person, there's a coherent one trying to get out. So this is exactly the illustration that I showed you in the beginning. The metaphor that there's some clever person inside us, Kahneman and Tversky say we don't share it. We suspect that incoherence is more than skin deep. They always use this fantastic language. Then similarly, Arke said the influence of incentive in eliminating association-based error is negligible. Now, Kammerer and Hogarth are more mixed. They say, on the one hand, they say there's no replicated study in which a theory of rational choice was rejected at low stakes and accepted at high stakes. But then on the other hand, they say high incentive does improve performance often, typically in judgment tasks that are responsive to better effort.
Maybe, Eldad, I want to say a little bit in defense of my friends Kahneman and Tversky. In one paper, they say that there it doesn't have effect. That doesn't mean they do it, they think it in general. In many papers, they did use real incentives. It was not their general opinion.
Thank you, Peter. They expressed this opinion in more than one paper. So they expressed this opinion in at least 5 different papers.
Yes, but that doesn't mean general.
All right. Fair enough. On the positive side, we find Hertwig and Ortman, who says that incentives do have a positive effect on judgment biases, but they do say that they matter more in some areas than in others, and they lead to convergence to performance criteria. And this is based on a review of 10 papers from the journal JBDM. Okay, so there are people that say that incentives do have a positive effect, but a lot of people say that they don't. What about meta-analysis of judgment biases? Branas Garza, Kuyal, and Lenke meta-analyzed the effect of incentives on the cognitive reflection test. The CRT is this well-known series of problems, the bat and the ball, etc., in which people typically make wrong judgments. And some studies have shown that when people are asked to deliberate longer, the rates of errors reduce, in some more, in some less. So, but the question remains, can performance be affected by incentive in this kind of judgment errors? And in parentheses, I said, on the positive side, you might say that cognitive effort improves cognitive performance. On the negative side, people say maybe people are bounded by their own strategy. So maybe if I get incentives, I would only apply my own strategy more enthusiastically.
And maybe Eldad, another thing is incentives can also have negative effect, like with crowding out effects.
Oh, definitely. Definitely. Branas Garza, on the basis of 110 studies and 40,000 participants, concluded that incentives actually didn't have a significant effect, with an estimated effect size of less than 0.01. So a very small effect size, actually consistent with this citation of Kahneman and Tversky that I showed you before. But some things should be said. First of all, this was not a standard meta-analysis. What they did was they collected raw data from studies that used the CRT and agreed to give them raw data, and then compare those studies that used incentives versus those that didn't. And of course, in comparison is between studies, and this kind of comparison, you have the potential for some moderators and confounding variables. They did do a regression analysis to control a variety of study-related factors, but of course, there might be some unexpected factors. Another thing is that in many cases, the incentives used was small. They had 110 studies, 17 of them used incentivization, and in more than half of them, the incentives are less than $1 or €1 per item. So our initial motivation for looking into this was to examine the suggestion that maybe small incentives didn't work so much, but maybe larger incentives had a larger effect on performance. But we found some more interesting things than that. Here are the 17 incentivized studies examined by Branas Garza, and we wanted to see what kind of money participants got. And we found that in 2 cases, it was not well defined. Lubian and Unterfoller, sorry for pronouncing it wrong, provided monetary incentives to 1 student in a large group, which the participant didn't know the size of the group, not even based on success, but based on carefully filling the questionnaires. So it's very vague. And the other one was Ibanez and Reiner. They offered a temporary position to 1 participant based on the result on a very large battery of tests, including the CRT question. So these studies did not give clear incentives for correct answers on the CRT. When we remove these 2 studies, we find that the simple effect of incentivization is significant. Recall that we are working on raw data. So actually raw data, it's not a meta-analytic technique. So we can do a simple correlation, and the correlation is 0.01 between having an incentive and not having an incentive and the performance. And this is equivalent to a Cohen's d of 0.20, a small effect size, very significant. We also find a positive effect for incentive size, d of 0.22. And we find no moderating effect for online participants. So this works for both online. This is not driven by online participants. We also find it when we use the same regression analysis that Branas Garza et al. Did. So controlling for a lot of variable, we maintain the small effect size of 0.19 to the effect of incentivization. So that was the surprising result. That actually, even without considering the size of the incentive, we still have a small positive effect size of incentives. Now, what about CRT studies that actually randomize participants into an incentive and a no incentive condition? Okay, so this is kind of a more rigorous way to examine this issue. We conducted a second meta-analysis that examined this. We identified 8 studies with about 3,000 participants, and you can see the list of studies here. And the results were, even though I should say that these are not the same studies, there is 0 overlap between these studies and the studies of Branas-Garza. These are different studies. Nevertheless, the effect size is almost exactly the same, D of 0.21, very significant positive effect of incentivization. Another interesting thing we discovered is that if you can see the distribution of effect sizes here, and you can see that most studies find more or less the same thing with small variance between them. And most of the between study variance was just estimated to be due to random noise. So our meta-analysis I-square index suggests that only about 70% or more than 70% of the variance is driven simply by random noise. So just random noise given a small effect size in the population. Okay? So to sum up, both of our meta-analysis of the CRT, cognitive reflection test, shows a small positive effect size for incentives on judgment performance. We then examined a classical judgment bias, the conjunction fallacy. So I might not phrase it completely correctly. So it's a basic tendency to estimate job probabilities as lower than the individual probabilities of the constituents, possibly due to focusing on prototypical similarity. So for example, here I try to devise an item of my own. I don't have, there's no guarantees for that because this is what was not run as an experiment. What is more likely in a hot day? You feel exhausted or you feel sweaty and exhausted? And I assume that all of us know that the correct answer is A, but you can see the lure, the temptation in answering B. And a lot of people fall into that because sweaty and exhausted sound more similar to a hot day. Okay, and of course, Tversky and Kalman used the Linda problem to investigate it. I will not iterate it fully because everyone are familiar with that. Linda is a 31-year-old single, outspoken, very bright. And you could say that Linda is a bank teller or active in the feminist movement or both, and both is a conjunction error. Now, less famously, in the same paper, Kalman and Tversky also argued that financial incentives do not help people see the light in their works. So, and they actually conducted an experiment to show this, which I will show you only if I have time. But this was not, by the way, a judgment study. It was a choice study, so it's not included in our meta-analysis of judgment studies. So we searched literature for conjunction fallacy and incentives. We found 11 studies that examined. Most of them used the Linda problem or the Bill problem, which is another problem used, developed by Kalman and Tversky. One of them didn't give incentives very clearly, so we examined what happens with it or without it, the same as previous. And here are the results. What we find when we use the conventional methods of log odds ratio is an odds ratio of 1.4, meaning that the ratio of successfully performing in an incentive condition is 1.4 higher than in a no incentive condition. And this is equivalent to a D of 0.19, highly significant. When we look at only the Linda problem, we get slightly higher, 0.24. Now, I should mention, so it's kind of similar to the previous result, a small positive effect size of incentivization. And again, we find that most of the between study variance was due to random noise, only 24% due to other factors besides noise. Now, I should hedge here and say that the log odds ratio method is highly sensitive to low baseline. It gives more weight to have low baseline in the control condition, and then you improve it in the experimental condition. When we use absolute risk differences, which are not sensitive to baseline, instead of odds ratio, the effect diminishes considerably to about half, though it's still significant. So I should admit that. And indeed, the studies that didn't show a performance boost were those where performance was very high to begin with, typically above 50%, for example, in ZEF and Awasti. So if you had high performance to begin with, you didn't improve much by getting incentives. So to sum up, there appears to be a small but robust positive effect of incentives on judgment performance. Incentives reduce judgment biases to a limited extent. Now, with the Cohen's D of 0.20, this means that most studies using small samples will actually not find a significant result. So if you use an N of 100 and you do a power analysis, you find that only 17% of the studies will actually find the effect that exists in the population to be significant. Obviously, with larger sample, this misrate diminishes, but it takes about 800 participants to get to an 80% power. So more generally, I should say that we should perhaps beware of dismissing small effect phenomena. First of all, and perhaps paradoxically, the sample size required to dismiss small effect phenomena is much larger than one expects and much larger than one needs to dismiss large effect phenomena. So for large effect phenomena, we don't need a lot of participants to dismiss them. But those small effects, we actually need huge samples in order to dismiss. Secondly, practically, small effect studies have been criticized because they are less applicable, okay? But this should be viewed, I think, and actually I also preach this in my research method course. I always tell participants, I always tell students, don't just look at statistical significance, also look at practical significance. If there's a small effect size, it's problematic. However, this, I think, should be looked at in context. Some manipulations, which are small in the lab, can be boosted, and their effect size is expected to increase. And at least according to previous findings, incentives is one of those manipulations. So usually most of the lab studies give small rewards. But if there are some evidence that also we find some evidence of when these rewards are increased, then their effect increases, their effect size increases. And also there are other ways to boost the effect size of incentives. One of them is to use losses. Studies have shown, including my own, that when losses are on the line, people work harder. Okay. The third point is more general. I think that as a scientific field, we should realize that some important effects are weak. So the fact that an effect is small doesn't make it invisible, doesn't make it zero, and doesn't make it not important. Maybe it's important but still weak. And this is existing and common in other scientific fields such as physics and biology, where small effect phenomena get their own respect. And just two examples of that is genetic mutations. In evolutionary biology, there is a lot of, it is argued that there's a lot of influence for genetic mutation that actually have small effects on their expression for various reasons. Even though they have a small statistical effect, they are important because of various reasons. And also in physics, I'm kind of working on a narrow scale here because I obviously don't know any physics. But if you talk about forces, there are some strong forces and there are some weak forces that are well respected. For example, the law of gravity. The gravity is considered to be one of the weakest forces in physics. Nevertheless, it's very important. And moreover, this weak physics force sometimes have weak effect sizes in other domains, such as in biology. I won't get further into that. How much time do I have, Yafim?
I think you have about 10 minutes, including
10 minutes, great. So if I have 10 minutes, then I'll devote 5 of them to show you Kahneman and Tversky's 1983 experiment, in which they actually showed no effect of incentives on the conjunction fallacy. So let's see what they did. Instead of a judgment problem, they actually used the following choice problem, which some of you might find familiar, okay? You are told something like this. Consider a regular 6-sided die with 4 green faces and 2 red faces. The die will be rolled 20 times, and the sequence of green sides will be recorded. You are asked to select one sequence from a set of 3. You will win $25. If the sequence you chose appear on the successive rows, please check the sequence that you prefer to bet. Now notice that these are the 3 possible answers. Now 2 seems more typical or representative if you think of random outcomes, but it's less probable. And you could see that actually 2 is just 1 and you add a G. So it's obviously less probable. It's 67% of 1. So it's less probable. So it's a mistake, it's a conjunction error. And in Kahneman and Tversky, there were 260 participants, 62% erred, selected 2 with no incentives, and 65% with incentives, and the effect was not significant. But there are some issues with this experiment. First of all, is that because it's a choice experiment, there are other reasons for error besides probability relations. So perhaps, for instance, participants didn't count the number of letters, and they didn't notice that there are more letters here than in 1. The other thing is that the incentive difference was very small. There's only a 7-cent difference between answering correct and incorrect. Now, some of you might say that I'm a little bit sour Peter might say that I'm a little bit sour for making these critiques. And I agree, I might be a little bit. But let me nevertheless add a couple more points. And the third one I think is perhaps the most important. If we really believe that there's a Cohen's d of 0.2 in the population and an n size of about 250, then the result should actually be significant in only 35% of the experiment. So we should actually expect most of the experiments to be insignificant. And indeed, Erev and Cohen, I was amazed to see that Ido Erev in the 90s ran an experiment on that. And also I was amazed to see that he always works with Cohens. Well, anyways, he ran an experiment and obtained a significant positive effect of incentives in this setting. So in some experiments you get it, and some experiments you don't. And this is what happened when you under an assumed small effect size in the population. So this is what I had to say.
Thank you. So now we have actually time for 2 or even 3 questions.
Well, maybe I can ask something. I think to what extent is it surprising? You know, some people, they defend hypothetical choice. They say that in particular experiments, it was as good as real incentives, or it was a bit worse. But I think almost everybody will agree that usually real incentives give somewhat better results than hypothetical choice. So to what extent is this surprising on you, what you presented?
Well, first of all, it depends what you mean by better results. So one has to be careful in defining what is better results. So we define better, so here we define better results as better judgment or selecting the option with a higher expected value. The other thing is that in a sense, I agree with you. I think that our findings, our conclusions are very gray in a sense. But for some reason in behavioral economics, a lot of people think that we are very special. And then in behavioral economics, the world is different. As there is no effect of incentives on judgment performance. And specifically on the conjunction fallacy and on heuristics.
David?
Yeah, thanks. Can you hear me okay?
Yeah.
That was a great talk, Eldad. I just wanted to ask about your CRT meta-analysis. If I follow the details, you found an effect size of about 0.2. The people who'd done the meta-analysis previously found an effect size of 0. And the difference was based on excluding 2 results, which seems to suggest that both of those results must have been quite strongly negative effects. And I just wondered, well, A, is that right? And B, is there any insight into what that might mean?
Okay, it's partly right. So first of all, they did have a negative effect. Secondly, what happens is that Branas Garza et al. didn't run the simple effect analysis that we did. They ran only the regression. So their 0.01 effect size is only under controlling for all of these factors. However, controlling for these factors has pros and cons. When you control for factors, you sort of filter the data, but you can also filter it for variance that is related to the variable in question. So there's some multicollinearity here. So if you do a simple effect analysis of their original data, retaining these 2 studies, you get an R of about 0.06 or 0.07 that is almost significant.
Sorry. The last question is for now from Rakefet, and then we will move to our second talk, and then we will have time for a bit more questions. Yes, Rakefet.
Thank you, Efim, and thank you, Eldad. I would like to point to some findings we have for metacognition that people under higher incentives tend to invest longer time and gain confidence only in the most challenging items and not in the easy items. So the easy items have less room for regulation, and the more challenging items carry more opportunity for regulation, in which people are motivated to invest more time in order to increase the gain with high incentive. I'm happy to share the data, and you can check whatever you would like to check, but it might be a new point of view on the data you analyze if you have response time and or confidence.
Yeah, we actually do a similar analysis, and we, as I said, we find that the effect is stronger when baseline performance is small. So we find a similar effect, but we don't have additional response time data.
Okay, I'm happy to share whatever you want.
We actually have time for one more question, probably. So Joachim, I thought you further raise your hand.
Oh, thanks a lot. I had a question. Did you make any attempts in your meta-analysis to control for publication bias to see whether null results or negative results are less likely to be published?
Of course, all of these meta-analyses include very strenuous publication bias examination, and just didn't present them here. And we don't find a publication bias. And obviously this makes sense because there are prediction either way. Usually you find publication biases when you have a very strong prediction in a certain field, and studies that don't follow this prediction are censored. But here we don't have a strong prediction and no censoring apparently, or no evidence of censoring. I also want to say to David that I agree with you that maybe just removing two studies is not very strong, but we also, even though the studies were not conducted like the others, but we also find the exact same effect when we ran the analysis for randomized studies that were different studies in our second meta-analysis.
Okay, that was the very last question, because that is answering very fast. Peter, you had a question?
Yeah, a remark maybe. In economics, people distinguish between experimental economists and behavior economists. They are in a state of war, and the main issue is the role of real incentives. Experimental economists blame the behavior for not reckoning with them. So Eldad, in your paper presentation, I would surely say something about experimental economists.
Thank you. I will do that next time.
Yeah.
Okay, Eldad, thank you so much for the great talk. As I said, after Carlos' presentation, we'll have time for both questions to Eldad and Carlos. And now, Carlos, the floor is yours.
Okay, can you see the slides now?
Yeah.
Good, perfect. So the title is Process Data and Economic Decisions, but it should really be Response Times and Economic Decisions, because when I sent the abstract, I was a bit over-optimistic. And I have to apologize if it's partly a bit of a rant, because as co-editor of Journal of Economic Psychology, I'm exposed very, very often to naive submissions, which I would define as typically being mainly behavioral economists submitting papers using certain process data from which in psychology we know a lot, but they don't even bother to read what we know and start speculating. And as an editor, you are really overexposed to these kind of things. So I realize this is not the audience to make this warning, but maybe you can spread the words that these things matter to us. So I want to give you a little bit of an overview of, in part, old stuff, in part, newer stuff, and specifically focus on response times. Well, choice data is limited. We know that it's a discretization of a continuous brain process. If I know that you chose A against B, I don't know how close you were to actually choosing B rather than A. I just know the discretization. And it's, of course, open to as-if theorizing, of which there is a lot in behavioral economics. Brain imaging process data, on the other extreme, is very expensive. And of course, we know that it would be ideal to complement every single behavioral study with brain data, but that's not realistic. Those are expensive machines, expensive data collection, is very time consuming, so sample sizes are going to be naturally reduced, which is not so good. Response times are cheap. So nowadays, we don't need metronomes anymore to collect response times. Computers record them now, whether you want it or not. So actually, every single experiment using the favorite behavioral economics software, set3, records response times, whether you want it or not, it's there. And there is a very extensive literature in psychology with the ABC of how to interpret response times in certain situations. I would put eye tracking somewhere in the middle. Eye tracking is certainly not cheap, but it's becoming cheaper. And there are new developments which allow you to have very cheap machines and have dozens of machines in a single lab, so costs are dropping. It's still time consuming, but it's certainly less time consuming than EEG over fMRI. So I'm very confident that we're going to see more and more eye tracking data in the future. So in the Journal of Economic Psychology, we welcome process data of all kinds. But there is one difference between us and behavioral economics. In economics, every time that you use process data, and I suffer a little bit of that myself, being in a department of economics, you have to justify why are you looking at it at all. Because process data is not economics, it's not of interest to economists, it's just a tool to explain something else. Well, as editors of the Journal of Economic Psychology, I think I also speak for Eldad for saying that at least in our journal, we are interested in decision processes, and hence we're interested in process data in itself, and we view that as a difference between economic psychology and behavioral economics. So process data is very welcome, but know the literature, we know a lot about it, and not all of it is intuitive. I want to give you a few examples about that, and very especially to those watching this lecture later and trying to explore the journal, please avoid naive introspection. The first example is the chronometric effect, or the chronometric function, many names, or strength of preferences, or however you want to call it. So if I show you these two lines and I ask you to tell me which line is longer, well, you are going to think this is a silly question, and you're going to give a very fast answer. And it's probably going to be correct for almost all of you. If I repeat the question between these two lines, okay, most of you are looking at it, most of you are still going to give the right answer, but practically all of you have taken a longer time. So that's 50 years of research in psychophysics. In discrimination tasks, humans make more errors and make slower decisions when stimuli are close, when decisions are harder. And we know a lot about that. There is overwhelming evidence going back to Cattell or even earlier, very well published, very, very unknown in economics, but very standard. This is also true for economic decisions. This is a paper just published with Michele Garagnani, where the task is not important, but it was about maximizing expected value differences in decisions under dominance. And then you can see that, of course, people are making a lot of mistakes when they are close to indifference, and that the fast response times are when the decision is very clear, when the differences are larger. And this is another paper in Journal of Risk and Uncertainty, where we estimated expected utilities out of sample and used those expected utilities to replot certain decisions between lotteries. And then you see the same kind of phenomena, even stronger, that when people are closer to indifference, there are more mistakes. And when they are closer to indifference, response times are longer. So let me call that the chronometric effect, that response times tend statistically to be longer when people are closer to indifference, when decisions are hard. So how do we model decision noise in economics? Well, we essentially steal a line from classical psychology, which is the Probit model of Thurston in Psychological Review 1927. Down the line, somebody, Daniel McFadden, got a Nobel Prize in economics for popularizing that idea in economics and giving it a name, random utility models. So, and essentially what you do is you say, well, the decision maker is going to choose X over Y, not if the utility of X minus the utility of Y is positive, but if that difference plus an error term is positive, which makes the event that X will be chosen a stochastic event, a random event, and it has a probability. Now, the nice thing of that is that if you assume a functional function for you, let's say Cara, Sierra, Ray, or whatever, and you assume a specific density function for epsilon, let's say normal, that's Probit, or extreme value 2, that's Logit, then this is econometrics. Utility estimation becomes a maximum likelihood problem with a lot of parametric and functional assumptions, and there is a veritable industry in microeconomics, very justified, trying to estimate utilities of people and doing welfare policy out of that. Well, we can go a bit further if we take into account response times. And in particular, we can get rid of all the parametric and utility functional assumptions and everything. So a random utility model with a chronometric function is just a random utility model where we add the observation that maybe there is a chronometric function which links realized utility differences, which are random, so everything is stochastic, to response times, and is decreasing. Maybe it looks like this, maybe it looks like that. So it's just modeling the chronometric effect because we know that's a zero order effect and adding it to our models. And then we can chunk out the math and start asking questions about preference revelation. We did that. That's a paper which came out last year in the Journal of Political Economy. And very informally, the main theorem in that paper says the following: is a stochastic preference revelation result. If you have data for choices between X and Y, and you have the distribution of response times, and you have the choice frequencies, then there is a certain condition, TWT, time will tell, which is not in this slide, it's in the next slide, so don't look for it. There is a certain condition such that if it is fulfilled by the data, then for every model of noise, so it does not matter whether it's probit, logit, or something else, whether it's symmetric or asymmetric, every model of noise, every chronometric function, as long as it's decreasing, but the exact shape does not matter, and every utility function, so CRA, CARA, whatever you want, shape does not matter, such that the model rationalizes the data, so the model reproduces the choice frequencies and the distribution of response times, then it follows that the utility of X is larger than the utility of Y. That means that if that condition is fulfilled by the data and you use the wrong model, you're assuming CARA when the truth is CRA, you're assuming probit when the truth is logit or whatever, you're still going to get the correct preference revelation. It's an incredibly robust result. So it's non-parametric, needs no functional assumptions or utility on noise. And essentially the trick is simply that I'm using far more data than classical results. I'm using response times that classical results could not use. So what this theorem allows you is to unequivocally distinguish noise from preferences. So it also solves a well-known problem in economics, which is the fact that just because you know that X is chosen over Y 75% of the time, that does not mean that the utility of X is larger than the utility of Y. You can invent a model where those are the frequencies, but actually utilities go the other way. That's actually very easy. So what is that condition? That condition is something like slowish errors, not slow errors, slowish errors. So if I reveal a preference for X over Y, ex post, choosing Y is an error. So that condition essentially says, ignore the fraction for a second. This is the distribution of response times when you choose Y, and this is the distribution of response time when you choose X. So this would be first order stochastic dominance. It would essentially say slow errors in the FOST sense. Well, it's not that, it's weaker than that, because it's the fraction of frequencies. And what's going to happen is that this implies ex post that the probability of choosing X is larger than the probability of using Y. So this is larger than 1. So it's weaker than FOST. If you have zero evidence from your choices, then this is 50-50, this is 1, this is still FOST. If you have a lot of evidence, this fraction becomes larger and larger, so PXY is closer to 1, and this condition becomes weaker and weaker. So the more evidence you have from choices, the less evidence you need from response times in order to obtain preference revelation, but it's using both. So in practice, what you do with this is you calculate choice frequency, you estimate the density of response times using some appropriate econometrics, check the condition time will tell, and if it holds, you have a stochastic preference revelation out of the response times, which is completely non-parametric and without functional assumptions. So in particular, you can rewrite that condition in such a way that you have just one fraction, one expression, and if that expression is positive, always positive, then you have preference revelation. So that's what I have done in this example. You have here this data set on food choice, and you have that for this particular guy, this is a person. I have 3 choice pairs where I obtain preference revelation and 1 where I don't. For this person, I have 13 choice pairs, and for most of them, I have preference revelation. So there is another result in that paper, which is also very intuitive. So if you have, assume for a second that noise is symmetrically distributed, then we can learn preferences from response times even when we don't have data. And the intuition is illustrative and intuitive. It's actually wrong. But let me tell you why it's intuitive, and then let me tell you why it's wrong. So intuition is the following. if I have data telling me that X is preferred to Z fast, whatever fast means, that's going to mean that the utility of X is larger than the utility of Z, but is much, much above. If I also have data that the utility of Y, that Y is preferred to Z slow, whatever slow means, that has to mean that the utility of Y is larger than the utility of Z, but it's closer, it's not that much above. So I cannot use transitivity because both of them are preferred to Z, but the utility of X is farther above than the utility of Y, so I should be able to conclude that X is preferred to Y. And actually we have a theorem which says exactly that, only fast and slow, these kind of statements have been made in the literature, and fast and slow have been made to mean average response time, median response time, the fastest response time, the slowest, whatever. All those results are wrong. They're all completely wrong. That's not the truth. That's not what the math says. Fast and slow, that's very naive. Fast and slow, what comes out of the math is something which is very intuitive. It's going to depend on how much information you have on the preference from the frequencies. So you are not going to use the median, you're not going to use the average, you're going to use a different percentile, which happens to be this one, for each choice. So you're going to compare a percentile for this choice pair with a different percentile from this choice pair, which factors in how much information you have from choice frequencies, and hence asks different things from the distribution of response times. So the idea is right, but the actual math for applying that is much more complicated than just taking an average response time. So let me not go into the detail of the math, and let me just give you a couple of examples of application. So we applied that to a data set on food choice where we have that kind of structure. So do you prefer Kit Kat to Reese's? Yes or no? Do you prefer Kit Kat to Mr. Goodbar? Yes or no? So a reference point. And then in a different part of the data set, we had the choices between Reese's and Mr. Goodbar. So we used the first part of the data set to estimate a full preference for each of the participants, and then compared it to the actual choices on the part of the data set that we did not use. We get 81% correct predictions, which is far better than you get usually because we are using more information, which are the response times. Recently, with Michele Garagnani and Ernst Fair, we have another application. We're actually looking at transitivity, but one of the things that we do there is do an application to risky choice. So we have a couple of data sets which have a structure that we can use. So choices are repeated a large number of times, and we have response times. This is one of the data sets. And in that data set, we have lotteries, and there is a reference lottery which was also compared to all the other lotteries. So we do the same. So we estimate preferences out of the comparisons with our reference lottery, and then we predict what are going to be the choices between the lotteries which don't involve the reference lottery, which we also have, but we didn't use for the prediction. And then we compare that to all those econometric models using CRRA, using CARA, using random parameter models, and so on. And our method actually outperforms all those models, which is maybe not so surprising because we are using more data. But maybe, again, it's more surprising because our method is completely non-parametric. So we are not married to any specific functional form. So second stylized fact about response times, and one which has been abused a lot in the last 10 years, especially in behavioral economics, dual processes. Okay, in psychology, we know that when we speak about dual processes, everything is a simplification. And we don't mean that there are just two processes, and we mean there is a continuum and so on. But of course, simplifications is what stays in memory, is what people repeat, and is what people use to make new designs and develop new applications. So dual process theories, essentially, in the simplification, are going to tell you that some processes are impulsive automatic and hence fast, and some processes are more deliberative and controlled and hence slower. And that has an immediate application for response times, which is that automatic processes are faster. The little problem is that I don't know of any method to observe a process. Not even with fMRI or EEG or whatever. Processes are not observable. Decisions are observable. So a fast response does not necessarily come from an automatic process. A decision process is a stochastic process. It's going to give you most of the time a certain response, but sometimes it's going to give you some other response. And response time is also going to be stochastic. So very bad theorizing that I'm seeing regularly in submissions to our journal is identifying responses and processes and skipping the discussion of the processes and just attaching the labels of dual process theories directly to their responses, which creates all kinds of trouble. So in particular, there is a paper by Ian Krivich, John Barling, Todd Hare, and Alos-Ferrer, which showed that if you assume that everything fast is automatic, that's going to lead to a reverse inference fallacy. So essentially what they did is show that in a bunch of experiments where you could interpret the data saying, oh, there is something fast and slow, dual process, and so on, actually it could also be explained by the chronometric function. Just because for some people, decisions are faster because they have a stronger preference, because the utilities are farther apart and nothing else. So if a decision has stronger idiosyncratic preference in favor of one alternative over another, those choices will be fast. It has nothing to do with dual processes. You can mix both things up very easily. So the predictions of dual process theories actually are not that fast is automatic. They are far more nuanced like that. And if you want to make predictions, you need to develop a proper model and say what are your assumptions and how are you putting things together. So for instance, let's use the diffusion model as a building block. Okay, so let's say this is a model of a process. Okay, so a process is just going to be a diffusion model with internal evidence accumulation. It's a diffusion process, it goes up or down randomly. There is a parameter which is the drift. If it hits the upper boundary, you go left. You hit the lower boundary, you go right. And that gives you response times. Okay, so here's a model, Management Science 2014, a more developed version in JBDN 2018. Which is a dual process model and it's a back of the envelope model. Suppose that we have two processes, the utility process, the heuristic process, and both of them are DVMs. And they have drifts, and the utility process have a relatively small drift, mu u, that's the reason that it's relatively slower. And the actual decision process comes from one process or another, and that's a random variable. I don't know how to model it, so it's a random variable. Back of the envelope model, completely analytically tractable model. So you can, for instance, and that's just a mathematical trick, normalize both drift rates to be positive so that maybe you have inverted one of the processes so that the upper barrier of one process is the lower barrier of the other. Just a mathematical trick. So then every process has a favored response, whatever is more likely, but every process can give you every answer. And now, if you have an experiment where the utility process captures normative thinking, then you can speak of correct responses and errors by definition. In some experiments it makes sense, in some experiments it doesn't. The heuristic process might now favor the correct option. We're going to call that alignment. That's where a heuristic is efficient, a cognitive shortcut, but it's going to be wrong in other situations, and we're going to call that conflict. And in every paradigm, you are going to have conflict and you're going to have alignment. Well, first thing, you can chunk out the maths. It's not very difficult. You can just compute the conditional error rates, the conditional response times, and so on. And you're going to find that the math says decisions under conflict are slow. And the main reason for that, even if you don't invoke conflict detection and resolution, is simply that correct decisions are slower under conflict than alignment because the heuristic process contributes many correct decisions in case of alignment, and those are fast, but few correct decisions in case of conflict, which means that when you condition on correct decisions, then you are going to bring the response time down when the heuristic process contributes many correct decisions, which is alignment. That is, of course, nothing else than the Stroop effect. That's a mathematical proof of why the Stroop effect should be there. You can also derive other predictions. So you can just say, okay, this drift actually comes from a difference in utilities or a difference in some salience function, which is depending on the type of heuristic. And then you have another prediction, which answers the old question of whether errors have to be slow or fast, a very, very old discussion in cognitive psychology. Neither. It depends. Neither and both. In case of conflict, on average, errors are faster than correct responses. The intuition for the math is simply that most errors come from the fast automatic process. So that's very simple. In case of alignment, however, on average, errors are slower than correct responses. And the intuition for that is simply that many correct decisions in that case are actually automatic, hence fast. So we took that to the data. On the left, you see a paper where we compared reinforcement, so win, state, lose, shift, versus Bayesian updating and I believe updating paradigm, pure JDM paradigm if you want. And you see the asymmetry that you're going to have one kind of relation under conflict and the opposite kind of relation under alignment. And on the right, you have a more recent paper where we used a paradigm called a Cournot oligopoly, which is interesting for economists. And we compared imitation, which I would say is a more automatic process than optimization, with myopic best reply, which is essentially one-step optimization. And you see exactly the same kind of asymmetry. And right now, Michele and I are going through data sets and already have like 40 different cognitive psychology data sets where you observe exactly the same kind of regularity. So this is very robust. And to conclude, if I have a couple of minutes, I just want to comment on what I consider third stylized fact, which is a non-fact, but it's a non-fact, the opposite of which is very often assumed in introductions of papers that I receive as an editor. So it's really getting a little bit on my nerves. Response time is not effort. I apologize, it really gets on your nerve when you see it again and again and again and have to answer to the author why you are rejecting that again and again. So the introduction of these papers that I'm getting all go the same way. Ignore psychology, ignore everything about response time, just say, you know, if I put more effort because I'm paid more, for instance, as Eldad was saying, so then I'll pay more attention, I'll be more careful, and that means that I will need more time. So time is effort. So I just did an experiment, I measured response times, and I'm interpreting literally response times as cognitive effort. And that's it. So I'm actually giving you results about response times, and my entire paper, my entire interpretation is cognitive effort. It really, really does not work like that. You can just not, without additional evidence, take a variable, call it something else, and give the interpretation based on the something else without proving that there is a relation, and there is no proof for that. So question, is this naive introspection? Is ignoring the literature? I don't know. What I know is that it is a test rejection at JOEP. Let me give you a quick example. This is a paper with Michele. It's not the point of the paper, it's just a very minor observation, a paper which is forthcoming in management science right now, where we had a belief updating task. And what you're seeing here is we had a treatment with low incentives and a treatment with high incentives. These are the high incentives. These are the low incentives. Oh gosh, response times go significantly down when incentives are increased. So according to this interpretation, that means that they are putting in less effort when we pay people more. Shock. Of course, no shock. Of course not. So higher incentives means that you're going to have larger differences in payoffs. Larger difference in payoffs, chronometric effect, means faster decisions. Done. That's as complicated as this is. It's a straightforward chronometric effect. There is a lot of that in the literature. That's one reason why you cannot get a measure of cognitive effort out of response times. Especially when you are doing behavioral economics and you are toying with incentives. How do you model cognitive effort? Well, I have a paper with Johannes Buchenmeier last year in Experimental Economics, where we try to do that in paradigms where steps of reasoning are clearly identified. So for instance, the beauty contest game or a bunch of paradigms in game theory where they use iterative thinking. And sometimes you get that. This is an example, so you should get at the zero. So the lower your answer is, the more iterations you have done. And indeed, that's given a longer deliberation time. But the problem is that in a paradigm like that, higher effort will make you take more steps. So deliberation time might increase, but the response time of each of the steps might go down. For instance, if you have increased the incentives. So the result is indeterminate, might go either way. Sorry, not a good idea. You need more information to be able to conclude that. And maybe the last comment on that, well, surely we can say something about cognitive load, right? How do you know that cognitive load has been successfully induced? Well, in economics, actually, we have a bunch of data showing that response times go down. So if I put people under cognitive load, they must put more effort, right? Response times go down. They go down to such an extent that we are proposing in behavioral economics to use a reduction in response times as a manipulation check that cognitive load has been correctly induced. And why is that? Well, dual processes. Less resources for deliberative processes, which means that decisions should be made more often by automatic processes, which are faster. End of proof. That's the entire intuition. And why has this not been observed in psychology? Because paradigms in psychology typically are simpler, more cognitive. Decisions are far faster than paradigms in economics, which means that the mechanical effects of cognitive law, which of course are going to increase response a little bit, might dominate, and you don't see these kind of things. And well, if you want to look at whether effort is increased by incentives, well, there is an alternative to that. Use pupil dilation. This is an example of a paper where incentives did nothing. That happens now and then, Eldad. So the question is whether the link between incentives increase effort breaks down, or the link between effort increases performance breakdown, because there are a lot of things. There is choking under pressure, there are ceiling effects, and so on. Which of the two links breaks down, and how do I observe that? Well, one way to observe that is pupil dilation, and what you see on the right is exactly where we're seeing that pupil dilation goes up, even though performance does not go up in this paradigm. So that's a better way to look at those questions. So in conclusion, response times are easy to collect. That does not mean that they are easy to interpret. The chronometric effect is out there, but everything is stochastic. Using that fact for prediction requires balancing frequency and response times. It's more complicated. Dual processes, okay, there are multiple dual decision processes, some faster than others, but decision processes are stochastic. You actually need to be specific in your assumptions and in your models and how you're putting things together. Deliberation time is definitely not effort. I have given you several examples of that. And the take-home message from all this is that we need more process data, and that we certainly welcome it in the journal. You can easily collect cheap process data. It is very useful, but it is not straightforward. Naive intuitions are very, very often wrong. Thanks for your attention.
Thank you. So unfortunately, we are almost running out of time. So maybe we have now time for one question. And then those who have to go will be able to go, and those who can stay for about 10 or 15 minutes more to ask both Carlos and that additional question. So, any questions to Carlos? There are not many questions yet, so I will ask one. And so basically what I understand, if I want to send a paper to your journal, it's better for me not to mess with the response times. Do I get you correctly?
No, quite the opposite. So you should definitely feel free to mess with response times, and to collect them and use them. What you should know is the literature, and not just speculate naively on what response times might mean. We know a lot about them, and especially there is a lot of evidence about what response times mean in psychology. So just, you should use response times, and they are very valuable, but you should really build upon what is already known in psychology. That's our take-home message.
But just one related to the journal, sometimes response time are not related to utilities. Like one extreme example, if editor of a journal send you a paper, say if I'll be too quick, you are very decisive. Your utility of the paper is very negative, but if you're too quick, the editor might send you another one. You wait 6 weeks, and this is an extreme example, but maybe there are more examples of that sort. Right. Sometimes it's it could be part of the utility. You gain some utility from slow reaction, right?
Yeah,
so that will mess up with your measurement of utilities.
Absolutely, I agree. And one of the points of why I am giving you different and almost orthogonal things is that there are many factors influencing response times. And actually, in the first part, when I talk about the chronometric effect, all that is under the assumption that I have data where I have shut down any kind of heuristic dual process effect and so on, or any extraneous effect like what you are talking about, and that I have data where it makes sense to interpret it just along that dimension. And the challenge right now is to try to put all these things together. But I completely agree. And also, what is the scale of response time that you are talking about? So if we are talking about response times in the lab, we're talking about decisions which are relatively fast. None of that can be extrapolated to the decision time of an editor to answer to a submission. I just had COVID the last 2 weeks and response times of the journal have gone up. Sorry, that's a stochastic shock. That's not in any of my models.
Okay.
Okay, guys. First of all, very interesting. Thank you. So those who have to leave can leave now, and I want to thank you for coming. And those who can stay, we will stay for, if it's fine with Carlos and that, we will stay for 10 or 15 more minutes to ask additional questions to both of you guys, if there are questions. And if there are no questions, I will follow up with one more question to Carlos. What you were talking about, maybe I'm completely wrong, it relates more to physical lab, right? Because from my experience, when I run experiments online, and if I try to measure response time, often what I get is noise. And noise because at least enter participants often do a few experiments in parallel. So there is no relation between the response time and their choices or whatever.
That's a very interesting question. I have mixed experience on that. I have been looking at a lot of online data. I mean, we're trying to switch a lot of experiments to online thanks or due to the pandemic. And we have two different kinds of experience. So for instance, we have survey data where we are applying the techniques that I spoke about in the first part. And the results are perfectly nice. And we are not seeing any difficulty. We just have relatively large data sets. And those are preferential choices. So those are not highly cognitive. Those are more like surveys about opinions and so on, trying to estimate really preferences for one political position or another. We are not seeing a lot of trouble for those kind of decisions. On the other hand, for decisions closer to judgment and decision making, for tasks where cognition, deliberation are important, then you're completely right. We are seeing a considerable increase in noise. And when you have a paradigm in the lab where error rates in a certain situation, let's say alignment, are 5%, and you go online and suddenly error rates there are 30 to 40%, you know that noise has increased a lot, and then you start being a bit suspicious of response times. So yes, I think I'm still hopeful that you can control enough of these with additional questions and selection and so on, and increasing the sample size, that even for more judgment and decision-making questions, online experiments are useful. But right now, my stance is preferential choices, online, no problem. More cognitive, be careful.
Thank you. Any